Tagamath, nananuta pa. May kenina. Manigaral tang ulit, bang mabiyasa. Allow me to guide you in learning the different concepts and skills in Mathematics 9. I am Teacher Andrew, your soulmate. Ready your self-learning module or learning activity sheets. In one of our previous episodes, we learned how to use table of values to represent a quadratic function. This time, given the table of values, we are going to determine the equation of the function. Let's have the first example. We will identify the equation of the quadratic function that this table of values represents. So, step 1, select any 3 ordered pairs from the table. For this example, we are going to use 0, 2, 1, 3, and 2, 6. Step 2, substitute each ordered pair in the general form of quadratic functions given by y equals ax squared plus bx plus c. And therefore, from the ordered pair 0, 2, it implies that when x is 0, y is equal to 2. Hence, we have the equation a times 0 squared plus b times 0 plus c equals 2. This can be simplified as c equals 2. Let's label this as equation 1. The ordered pair 1, 3 implies that when x is 1, y is 3. Hence, we have the equation a times 1 squared plus b times 1 plus c equals 3. This can be simplified as a plus b plus c equals 3. Let's label this as equation 2. The ordered pair 2, 6 implies that when x is 2, y is 6. Hence, we have the equation a times 2 squared plus b times 2 plus c equals 6. This can be simplified as 4a plus 2b plus c equals 6. Let's label this as equation 3. Hence, we have a system of linear equations in 3 variables. Step 3, solve for the values of a, b, and c in the system of linear equations. In the system we wrote, equation 1 already displays the value of c, which is 2. We can substitute this value in equation 2 and 3. So we have equations 4 and 5. a plus b plus 2 equals 3, and 4a plus 2b plus 2 equals 6. We can continue solving the system using equations 4 and 5. And we may use elimination method. I am thinking of eliminating the variable b. Hence, I need to multiply both sides of equation 4 by 2 so that the coefficient of b will also be 2, just like in equation 5. Thus, we have equation 6. 2a plus 2b plus 4 equals 6. So, we now subtract equation 6 from equation 5, since they both contain the term positive 2b. 4a minus 2a is equal to 2a. 2b minus 2b is equal to 0, so variable b is eliminated. 2 minus 4 is equal to negative 2, and 6 minus 6 is equal to 0. Hence, we have equation 7. 2a minus 2 equals 0. This means that 2a is equal to positive 2. And dividing both sides by 2, we get that a is equal to 1. Let's now solve for b. I opt to use equation 4, where a plus b plus 2 is equal to 3. By substituting the value of a, we have 1 plus b plus 2 is equal to 3. This means that b plus 3 is equal to 3. This means b is equal to 0. Now, since a is 1, b is 0, and c is 2, the equation of the function written in general form is y equals x squared plus 2. Let's have another example. Here's the table of values. Just a tip when you choose the ordered pairs. Always pick the pair in which one of the coordinates is 0. So, from this table, let us use 1, 0, 2, negative 3, and 5, 0. And these are the equations I can form. Using the ordered pair 1, 0, equation 1 is A plus B plus C equals 0. Using ordered pair 2, negative 3, equation 2 is 4A plus 2B plus C equals negative 3. Using ordered pair 5, 0, equation 3 is 25A plus 5B plus C equals 0. Since all equations in the system contain the term C, we may eliminate the variable. We could do the following. Subtract equation 1 from equation 2. Hence, equation 4 is 3A plus B equals negative 3. Subtract equation 3 by equation 1. Hence, equation 5 is 24A plus 4B equals 0. We can continue solving the system using equations 4 and 5. And again, we can use the elimination method. And here, I wish to eliminate variable b. So, we have to multiply both sides of the equation 4 by 4 so that b will have the same coefficient as the b in equation 5. Hence, the equation 6 is 12a plus 4b equals negative 12. We now subtract equation 6 from equation 5. Hence, equation 7 is 12a equals 12. Dividing both sides of the equation by 12, we obtain that the value of a is 1. Let's solve for b using equation 4. By substituting the value of a, we have the equation 3 times 1 plus b equals negative 3. This means that 3 plus b is equal to negative 3, and b must be equal to negative 3 minus 3. Hence, the value of b is negative 6. Let's now solve for c using equation 1. By substituting the values of a and b, we have the equation 1 plus negative 6 plus c equals 0. This means that negative 5 plus c is equal to 0, and which means the value of c is 5. And so, the equation of the function is y equals x squared minus 6x plus 5. This time, given the graph of a quadratic function, we will determine the equation. And there are 3 cases for this. Case 1, using 3 points on the parabola, excluding the vertex and the x-intercepts. Let's see our first sample graph. What are the 3 points on this parabola that you can identify? Other than the vertex, the following points are on the curve. We have 3, 4, 5, 4, and 6, 10. And just like what we did when we identified the equation, given the table of values, we are going to substitute these identified ordered pairs in the general form y equals ax squared plus bx plus c. So we have the following equations. Equation 1, 9a plus 3b plus c equals 4. Equation 2, 25a plus 5b plus c equals 4. Equation 3, 36a plus 6b plus c equals 10. Since all of the 3 equations in this system contain the term c, we may eliminate this variable, and we do the following. Subtract equation 1 from equation 2. Hence, producing equation 4, 16a plus 2b equals 0. Subtract equation 1 from equation 3, thus producing the equation 5, 27a plus 3b equals 6. We can now continue solving the system using equation 4 and equation 5. If we wish to eliminate the variable b, then we have to make the coefficients of this variable in both equations equal. But how? 2 and 3 are the coefficients of b. Their LCM is 6. Thus, we must multiply both sides of equation 4 by 3 to make the coefficient of b 6, while both sides of equation 5 must be multiplied by 2. Hence, the equations
48a plus 6b equals 0.
and 54a plus 6b equals 12. Now, let's subtract equation 6 from equation 7. Hence, the equation is 6a equals 12. This means that a is equal to 2. The leading coefficient is greater than 0 or positive, and this explains why the parabola in this example opens upward. Let's solve for b using equation 4. 16a plus 2b equals 0. By substituting the value of a, we have 32 plus 2b equals 0. This means that 2b is equal to negative 32. Hence, b is equal to negative 16. Then, let's solve for c using equation 1. 9a plus 3b plus c equals 4. By substituting the values obtained for a and b, and then solving for c, we get that c is equal to 34. Hence, in general form, the equation of the function is y equals 2x squared minus 16x plus 34. Case 2. Using the x-intercepts and another point on the parabola other than the vertex. Let's see this parabola. Here, it is indeed hard to identify the coordinates of the vertex, so we have to rely on the x-intercepts and another point on the curve. The x-intercepts are negative 1 and 2, and also on the curve is the point 1, 6. We substitute these in the intercept form. Y equals a times the binomial x minus r times the binomial x minus s, where a is the leading coefficient and r and s are the x-intercepts. Plugging in the x-intercepts negative 1 and 2, we have the equation y equals a times the binomial x plus 1 times the binomial x minus 2. The ordered pair 1, 6 means when x equals 1, y is equal to 6. So, we can rewrite the equation as a times the binomial 1 plus 1 times the binomial 1 minus 2 equals 6. The equation can be simplified as negative 2a equals 6. Hence, a equals negative 3. The leading coefficient is less than 0 or is negative. This explains why the parabola in this example opens downward. Thus, the intercept form of the equation of the function is y equals negative 3 times the binomial x plus 1 times the binomial x minus 2. In general form, it can be expressed as y equals negative 3x squared plus 3x plus 6. Case 3. Using the vertex and another point on the parabola other than any of the x-intercepts. Let's see this parabola as an example. The vertex of the parabola is the point 1, negative 4. The x-intercepts are hard to identify and seem to be non-integers. But one point on the parabola we could easily identify is given by the ordered pair 2, 4. We will substitute these in the vertex form y equals a times the binomial x minus h quantity squared plus k. Since the vertex of the parabola is 1, negative 4, the equation can be written as y equals a times the binomial x minus 1 quantity squared minus 4. A is the leading coefficient. To solve for a, we have to plug in the values of x and y given by the ordered pair 2, 4. So we have the equation a times quantity 2 minus 1 squared minus 4 equals 4. This means that a minus 4 is equal to 4. Hence, a is equal to 8. The leading coefficient is positive or is greater than 0. This explains why the parabola in this example opens upward. And therefore, in vertex form, the equation of the function is given by y equals 8 times the binomial x minus 1 squared minus 4. In general form, this is expressed as
y equals 8x squared minus 16x plus 4.
At this point, we will determine the equation of the quadratic function given only the zeros of the function. Say y is a function of x. The zeros of the function y are the values of x at which the value of the function y is 0. Graphically, the zeros of the quadratic function are the x-intercepts. Hence, we will be using the intercept form to arrive at the equation of the function. Let's have the first example. The zeros of the function are negative 4 and 11. So, y is equal to a times the binomial x plus 4 times the binomial x minus 11. And since no information is given about the leading coefficient a, we may arrive at a family of quadratic functions corresponding to this equation. Just remember that a is a non-zero constant. So, if a is equal to 1, then y is equal to the binomial x plus 4 times the binomial x minus 11. In general form,
Y equals x squared minus 7x minus 44.
if a is equal to negative 1/2, then y must be equal to negative 1/2 times the binomial x plus 4 times the binomial x minus 11. In general form, y must be equal to negative 1/2 x squared plus 7 over 2 of x plus 22. Another example, the zeros of the function are negative 2 plus or minus 3 square root of 3. For convenience, we could let the radical number 3 square root of 3 be, say, z. So the zeros can be expressed as negative 2 plus or minus z.
Let's also assume that a is equal to 1.
So, y is equal to the binomial x minus the quantity negative 2 plus z times the binomial x minus quantity negative 2 minus z. Using the FOIL method, y must be equal to x squared minus the quantity negative 2 minus z times x minus the quantity negative 2 plus z times x plus the quantity 4 minus z squared. To combine the similar terms, we should subtract the coefficients of x. So we have the negative of the quantity negative 2 minus z minus the quantity negative 2 plus z. This can be simplified as 2 plus z plus 2 minus z. Rearranging the terms so that similar terms are beside each other, we have 2 plus 2 plus z minus z. And this is equal to 4. Hence, the coefficient of x is 4. Thus, y is equal to x squared plus 4x plus the quantity 4 minus z squared. Since the binomial enclosed in the parenthesis is preceded by a plus sign, we may just remove the parenthesis without reversing any sign. So, y is equal to x squared plus 4x plus 4 minus z squared. What is the value of z squared? Recall that we let 3 square root of 3 be equal to z. Therefore, z squared must be equal to the square of the quantity 3 square root of 3. And z squared must be equal to 9 times 3 or simply 27. Therefore, y is equal to x squared plus 4x plus 4 minus 27. Combining the constants, y must be equal to x squared plus 4x minus 23. And this is already the equation of the function in general form. That has been another learning-packed mathathon, Kagamat. May you always find what defines you. This has been your Solvemate, Teacher Andrew. See you in the next episode. Bye!